Single wall versus double wall radiography explained. In radiographic testing, pipe diameter changes the entire inspection setup. Small diameter pipe, large diameter pipe, vessel welds, and flat plate all require different radiographic techniques to produce interpretable images. In this module, we are covering 3 common methods: single wall exposure, single wall viewing, or SWSV, double wall exposure, double wall viewing, or DWE/DWV, and double wall exposure single wall viewing, or DWE/SWV. Understanding the difference between these techniques is critical because geometry controls image quality in radiography. Why do some pipe welds use one wall while others use 2? The answer is geometry. Pipe diameter directly controls the radiographic technique. With small diameter pipe, the weld images tend to overlap on the radiograph. There simply is not enough separation between the walls to isolate a clean image. As pipe diameter increases, image separation improves. That allows the interpreter to evaluate a single wall with less superimposition and better clarity. Technique selection matters because it directly impacts flaw visibility, interpretation accuracy, and code compliance. Single wall exposure. Single wall viewing, or SWSV, is one of the cleanest radiographic techniques. In this method, radiation passes through only one wall thickness before reaching the film. The radiograph records a single weld image with minimal overlap. This technique is commonly used on flat plate, large diameter pipe, and pressure vessel welds where geometry allows proper separation. The main advantage is improved interpretation quality. There is less image superimposition, better flaw visibility, and cleaner radiographic definition. When geometry allows it, SWSV is usually preferred because the resulting image is easier to evaluate accurately. Double wall exposure. Double wall viewing, or DWE/DWV, is commonly used on small bore pipe. In this setup, radiation passes through both walls of the pipe, and both walls appear on the radiograph. This technique is typically used on pipe around 3.5 inches in diameter and smaller because the geometry prevents clean single-wall imaging. The downside is image overlap. Both walls are superimposed on the film, which can make interpretation more difficult. But in small diameter piping systems, DWE/DWV is often the most practical and code-acceptable solution. Double wall exposure, single wall viewing, or DWE/SWV, is commonly used on larger diameter pipe. In this method, radiation still passes through both walls, but only the wall closest to the film is evaluated. As pipe diameter increases, the weld images separate enough that the interpreter can focus on a single wall image rather than overlapping indications. The goal is to reduce superimposition and improve interpretation accuracy while still working within the geometric limitations of pipe radiography. This technique is very common in refinery, pipeline, and pressure piping work. Pipe diameter changes everything in radiographic testing. With small diameter pipe, weld images overlap because beam separation is limited. That usually requires double wall viewing techniques. As pipe diameter becomes larger, weld image separation improves. That allows single wall viewing techniques with cleaner interpretation and better sensitivity. This is why radiographic procedures often specify different techniques depending on nominal pipe size, wall thickness, and source arrangement. The geometry of the part directly controls the quality of the final radiograph. Source and film placement are critical in radiographic testing. Several variables affect image quality, including source-to-film distance, pipe diameter, wall thickness, access limitations, and geometric unsharpness. Poor setup can create distortion, loss of definition, or excessive blur on the radiograph. The overall goal is to achieve interpretable image quality while maintaining the required code sensitivity for the examination. In real-world production environments, inspectors often balance ideal technique against practical access limitations in the field. Radiographic testing always involves real-world limitations. Superimposed images can hide discontinuities or make interpretation difficult. Geometric distortion caused by poor placement or improper setup can reduce radiographic clarity. Access restrictions are another major issue, especially around structural steel connections, pipe racks, vessel internals, and congested process piping. And sometimes the perfect shot simply is not possible. That is why radiographic testing is not just about equipment. It is also about judgment, geometry management, and practical code application. Bottom line, small diameter pipe often requires double wall exposure. Double wall viewing techniques because image overlap cannot be avoided. Larger diameter pipe may allow double wall exposure, single wall viewing, or full single wall exposure single wall viewing techniques with improved interpretation quality. Pipe geometry controls the technique selection, and technique selection directly impacts flaw interpretation. In radiographic testing, image quality is fundamentally a geometry problem. RT is really about geometry management.